All right, so that's the combination measure. Moving right along, our third output that we're looking to get. So on my side panel here, I want to know what kind of flushness that I'm seeing all the way around. So I've chosen these kind of 11 cross sections, and I want to check the flushness between 2 points at each of those sections. So if I go to my 3DCS model, I've already created points. So if I go zoom in right here, we'll see I have a blue point on my side panel. Then I have a black point that's corresponding to roughly that same position on my platform rail. So what I want to check is just how flush are these 2 points. Nominally, they're supposed to be perfect, but we all know that with some variation, you can end up with it being a little bit off.
So one of the things I want to say is he mentioned that, roughly in the same area. Those 2 points do not have to be in the exact section because the point-to-point measure is measuring project along a vector. So long as, they're in the area, it's going to project it along the vector and tell you what the flushness number is. So you don't have to kill yourself to get the points directly in.
So like I said, I have these points that are kind of paired up at different intervals along this perimeter here. I think I have a total of 10 points, 3 on each side, 4 across the top. And in my opinion, the most powerful way to check all 10 of those at once and just get one data set out of it is a measure called the 2-point list measure.
There we go. I was a little premature.
So Gary previewed this one a little bit earlier because, in effect, it really just is point distance measure and combination measure flattened out into just one measure. So that instead of having 10 point distance measures and then a combination measure to return to me what the minimum one is and what the maximum one is, now using just one measure, I can get 2 lists of points. And I can return to myself, the minimum value for all of those measures or the maximum value for all those measures.
Yes, perfect.
So like I said, combine several point distance measures into one measure with one output. So the inputs for this one are going to be 2 lists of points, and these are corresponding points. So like I was just showing you on the side panel and on the platform railing, I have several points that are corresponding to each other. So I'd have group 1 over here would have my first flushness point, and then its corresponding point would have, or the second point here would have that corresponding point that I have on the platform rail, actually.
So this is where, hopefully when he generates the measure, this is where your naming convention can become very helpful.
Yeah.
Because then you can pick your points off of the tree, and it's very fast.
Yeah, and so these are, again, best used for gap flush measures, especially all the way around ones like this where you're trying to check several different locations at one time. And then, a min-max check across several similar measures. So if I go back into my 3DCS here, here's an example of a 2-point list measure. So if I zoom out here, you'll see that kind of 10 arrows are showing up all around at those 10 locations that I called out earlier. And that's because inside of this 2-point list measure, I've got my 10 points on the left side, 10 corresponding points on the right side. Can I expand this out? There we go. So you can see that 10 is all the way at the bottom here, 10 is all the way at the bottom here, scroll all the way to the top, we got 1 at the top, 1 at the top. Seems like all my points are probably there. And then the other important point to note here is that you only do get one direction input for this measure, so I can't customize what type in direction I want for each of these measures. If I do choose associate direction, then it does take the associate direction for each of the pairs. So you can see that my points around the corner here don't have the same direction as each other. But if I were to change this to type in and leave that as 100, for example, and hit apply, we'll see that they all change to have that same 100 direction, which is not what I want in this case. I do want all of them to be measured across their associate direction. So I'm going to change this back to associate direction in this case. Typically, I'd say for this one, you're going to want to leave this as associate direction and allow the points that you select to drive the direction that you're measuring in, rather than customizing. And
this direction is coming from the object field again.
Yes, exactly. So one other point here, the measure type field up here, got a lot of different options for this one. So I think it defaults to all points min maybe. I usually use pair points min or pair points max, and that's like I was saying before, I have these corresponding pairs of points, and I only want to measure between point 1 and point 1, point 2 and point 2, point 3 and point 3. If you choose all points min, then it's going to measure between point 1 and then 1, 2, 3, 4, 5, all the way to 10. So we're going to have 10 measures for point 1 here, 10 measures for point 2 here, 10 measures for point 3 here. And my result is going to be wildly different from what I'd expect, because at some point, we're measuring from
you're going to get
point 10 here exactly to point 1 over here, and that's going to end up being negative 12, 19.2 along that vector direction. So I guess if you ever do a 2-point list measure and your results aren't really making sense, this could be a culprit, I'd say.
Yeah, the all points min could be used if you put a mesh of points on two surfaces that have contours, and you were trying to simulate our feature measure.
Yep.
You would mesh points on both surfaces and do all points min, and it would crisscross and look for any kind of crash.
Yep.
But the key too is he's using pair points min or pair points max, hence the word pair. So those pairs have to be lined up correctly, and you can have a lot of points in your list. And so the other thing that's key to note is that reorder button. Because if you misselect your points, you don't want to start over. You just want to reorder them, and so you don't have to do it.
Just add a couple. You can click select all, and then it'll add them all in order. So
right. So the idea is you pick, one, label your points correctly so you can pick them off the tree. Then if you still mispicked them, you can reorder them in the dialog box instead of starting over.